Welcome to the Kicking Off Third Grade Math Workshop. I'm Megan from the Math Workshop, and I'm so happy that you're here. I want to thank you for taking the time to dive deep into all things third grade mathematics. My hope is that we will add to your toolbox of ideas and activities to support your mathematicians and helps you set the stage for a fantastic year of learning. Let's take care of a little housekeeping first. This workshop is for 2 hours, so feel free to pause it, rewatch it, whatever works for you. In the email that we sent to you that had the link for this workshop, there was also a note-taking guide, so it follows along with the workshop. So feel free, if it works for you, to print it out and take notes while we're learning. Also, within that email, you should have seen a link to a math routine sampler slide deck. Oh, we hope you really enjoy that with your mathematicians. Also, as well, there were 3 math games that we sent to you and geometry word wall cards to print out and put on a bulletin board to support your students, as well as a certificate of completion for this workshop and a Survey Monkey link. Oh, we really appreciate in advance you considering taking the time to fill out that feedback for us. Let me take a moment to introduce myself if we haven't met. My name is Megan Brewer, and I'm the creator of the Math Workshop. We support a community of mathematicians who believe that learning math to the deepest levels is possible for everyone. At our core, we're committed to making mathematics learning fun and engaging while ensuring that instruction centers on making sense of concepts. We provide the tools and resources for students of all ages, including hands-on manipulatives and visual aids that help unlock the connections and the relationships between mathematical concepts. We believe that learning through investigations provides a framework for developing essential problem-solving skills and critical thinking skills while promoting a growth mindset. I'm a former elementary teacher. I was a math coach at a Title I K through 6 school. I worked for a large school district in the curriculum office where my job was to share research-based strategies with educators in my district to ensure that multilingual students would have access to grade level mathematics. I've also worked as an educational mathematics specialist consultant, traveling the United States, providing workshops and courses around all areas of mathematics for teachers, and doing coaching and model lessons. I've also worked as a curriculum designer and editor. And now my favorite current roles are teaching students in my local community and supporting educators and homeschool parents locally and across the country to help them as they teach their children mathematics. I currently live in North Carolina, and I'm a mom of 2 teenagers, and we have many fur babies. I love to travel, and I'm a voracious reader. Here is our workshop agenda. We're going to explore third grade math standards. We're going to examine the math tools, the representations, the manipulatives to support your students' understanding of those math standards. And we're going to look over math routines, what they are, how you can use them. We're going to work on combining the third grade math standards with the math tools. That seems to make a lot of sense. These are the 5 domains for third grade mathematics. We have operations and algebraic thinking, number and operations in base 10, number and operations in fractions, measurement and data, and geometry. These are the big ideas of third grade math. Developing an understanding of multiplication and division. That's a big one. Strategies for multiplication and division within 100. Understanding of fractions, especially unit fractions. Understanding the structure of rectangular arrays and of area. And describing and analyzing two-dimensional shapes. During this math workshop, we're really going to focus on these three. Let's take a deep dive into the third grade math standards. As we explore the standards, we will make them applicable with examples. Let's first focus on the multiplication and division standards. Third grade is really the first formal time that multiplication and division show up in the standards. Now, in second grade, students do examine repeated addition. So 2 plus 2 plus 2 is 6. And that concept of repeated addition lays the foundation for multiplication. So that's 3 groups of 2, 3 times 2 equals 6. That's third grade. Additionally, second graders are expected to explore arrays, examining rows and columns with items. It might be little inch tiles, it could be little two-sided yellow and red counters. So that idea of that array model with rows and columns and seeing again that repeated addition. So they're laying the foundation for third grade multiplication. Let's watch a fantastic video that we want to share with you from Graham Fletcher, and it's on the progression of multiplication, which really will help us think about how to best support our third graders as they begin to explore multiplication. So we're going to watch a little more than half of it. We're going to stop when he gets to the end of third grade content.
Oatmeal.
No. Cold pizza.
No. Eggo waffles.
Yes!
You both said yes to something.
So, here's my attempt to explain the progression of multiplication. Well, most of us might think it starts in third grade, but in actuality, it starts in second grade, where students are expected to take a square or a rectangle and partition that square into no more than 5 rows or 5 columns. Here, the understanding of repeated addition is established. 5 plus 5 plus 5 plus 5 plus 5 is 25. Then, in third grade, students take that understanding they've begun to develop in second grade and begin to construct arrays using square color tiles, or any manipulative for that matter. The important piece is once they've actually constructed that model, they draw a pictorial representation which matches their model. Here we have 4 rows of 6, or it could also be seen as 6 rows of 4, depending on how you turn the model. And the big piece here is that we don't push an understanding on students, we let students explain what their model represents. The big piece is that the context will explain the equation, not the teacher. Then we take that understanding and we come back to the biggest piece probably in third grade, which is that there's a relationship happening here. And that relationship is taking place between multiplication and division. Take this, for example. 12 divided by 4 is a number. 4 times what number is 12? Well, if we take 12 tiles and we put them in 4 rows until we run out, we actually see that we have 3 in each row. So there's a connection between multiplication and division, and arrays can be used for both. The context. Yep, let's go back to it. Here's a simple one. There were 3 packs of pencils. Each pack had 40 pencils. Well, at the beginning part of multiplication, students might do something like this, where they draw out 3 circles, and in each circle they put in 4 10 rods, so 40. Or they could actually go ahead and draw 40 little pencils. That's great. But the standards of mathematical practice, and in particular number 7, want us to be efficient. And one way to do that is we can begin to make use of structure. And when we do, we make sense of it. Here we begin to create an area model for multiplication. very much like an array, just on a bigger scale with larger numbers. So 3 times 40, we take it, build it out of 10 rods. We have 10 tens, which is 100, plus 20 is 120. Or it could also be seen as 12 tens. Really big understanding for students. Once students have established this, they should be diving into drawing pictorial models for what they're concrete. Again, we don't want them to be sitting there with manipulatives all the time. So we move them away and they begin to draw a pictorial representation for what their concrete model looks like. Then from there, we'll have them use numbers to represent their picture. All of the time, connections are being made. Then, eventually, after multiplying all of these ones and tens, students begin to collect and group numbers together. Now we're beginning to become efficient thinkers. The connections are being made all around because students are exploring. In 4th grade, students are
Wasn't that a great video? Feel free to watch it again. I know every time I watch it, I get something different out of it. So Mr. Fletcher mentioned the CRA model of teaching math. This model has its roots in the work of psychologist Jerome Bruner. Bruner's theory of cognitive development, specifically the stages of representation, heavily influenced the development of the CRA approach. The CRA model is a 3-stage learning process where students first experience concept with concrete objects, then move to pictorial representations, and finally to abstract symbolic notation. While Bruner's ideas laid the foundation, the CRA model was further developed and popularized in the 1980s, with Singapore's Ministry of Education adopting it as a key teaching strategy. Here's a visual image to help us think more about the CRA approach. Notice that the bottom of the pyramid is a foundational level. This is where we should be instructing students first with any math concept through hands-on math tools, concrete objects, or manipulatives. You see the M&Ms in the bottom of the left-hand side of the screen. So that's a concrete model representing the 3 groups of 3 M&Ms in each group. 3 times 3 is 9. Also, on the other bottom side of the screen on the right, you see 3 red clothespins and 2 blue clothespins because 3 and 2 equals 5. Then we move up to the representational or pictorial or drawing model. As Mr. Fletcher said in his video, we don't want kids to stay in the concrete mode. After a while, we want them to transfer that learning they were doing with their hands-on manipulatives to sketches or drawings, which represented that thinking. So you see that on the screen with, on the left, the 3 rows of 3 red circles. 3 rows of 3, 9. 3 times 3 is 9. And also on the other side, you see the 3 red dots and the 2 blue dots. 3 plus 2 is 5. Then the last level. So once students have had their hands-on experience, then they're sketching and drawing their thinking and the operation or the concept. Then they move to the abstract. And that's simply using numbers and symbols to represent your thinking. So those are the equations that you see on the top of the screen. Another model that is typically used by math educators that is related to the CRA model is the Lesch model. The Lesch model, also known as the Lesch translation model, originated from the work of Richard Lesch in 1979. It's a framework in mathematics education focused on the importance of understanding mathematical ideas through multiple representations. So that's what's going on with the circles, and the ability to translate back and forth between them. So notice that all 5 circles, which we'll go over in a minute, have arrows and lines going through all of them. So they're all connected. Let's look at them. You have the pink circle. That's the concrete model. That's exactly like the C in the CRA model. That's hands-on manipulatives. Then you have the orange circle. That's the visual model. That's the same as the R in the CRA model. So concrete representational. So that's the drawings, the sketches. Then you have the yellow circle. That's a symbolic mode. And that's the same as the A in the CRA model. That's abstract. That's the using numbers and symbols, the equations to represent your thinking. But additionally, on the bottom, we have the green circle. That's verbal. So that involves students having discussions about their thinking, sharing verbally how they solved a problem or what they're thinking about. They're sharing their reasoning and their justification. Then next to it, we have that teal circle, contextual. So those are the word problems or the story problem or the context of the problem, the real world context. So for example, an example might be if I wanted to share 36 cupcakes among 3 classes, how many cupcakes would each class get? So the beauty of this model is that there's a lot of power in giving students the opportunity and the invitation to explore all 5 of these representations. Then their thinking and their understanding of that mathematical idea is going to be so much more powerful. I know when I was in elementary school, I only had the opportunity to focus on the yellow, the symbolic. So just writing the numbers and the equations and greater than, less than, so just numbers and symbols. And I know for myself as a student, I would have greatly benefited from being exposed to the other 4 domains in that diagram. How about you? Here's an overview of 3rd grade multiplication and division, big ideas, representing and solving problems involving multiplication and division, understanding properties of multiplication and the relationship, that inverse relationship between multiplication and division, and multiplying and dividing within 100. We are going to explore these at a much deeper level. So let's look at developing an understanding of multiplication and division. Students develop an understanding of the meanings of multiplication and division of whole numbers in 3rd grade through activities and problems involving equal-sized groups, arrays, area models, multiplication is finding an unknown product. 5 times 9 is something. What is the unknown product? And division is finding an unknown factor in these situations. So 45 divided by 5 is something. What's that unknown factor? That when I multiply times 5 gives me 45. For equal-sized group situations, division can require finding the unknown number of groups. So in this example, we have all of those hamburgers. How many groups are there? That's what we're finding with this equation. 20 divided by 4 equals 5. There are 5 groups. For equal-sized group situations, division can also require finding the unknown group size. So what is the group size? There are 4 in each group. Let's hover around these math standards for a moment and consider the math tools which can bring these abstract concepts to life for our students. But first, let's pause and let's be gentle with ourselves, okay? Most of us probably did not learn math in elementary school with many, if any, tools. I know for myself, I don't remember any tools, not one. And I'm here to share that I mostly did not know why I was performing the steps for the algorithms that I was doing. I didn't know why. I tried to memorize my multiplication facts and steps to solving problems, but honestly, I made a lot of mistakes because I didn't have the foundational understanding to support those procedures. I didn't know why I was doing what I was doing, and I didn't always remember what to do. Well, today's math standards call for students to blend the perceptual knowledge, and that's how I learned, maybe you too, with memorizing and following steps. But today's standards want you to blend that procedural knowledge with conceptual knowledge. That's what was missing for me that I needed. The conceptual knowledge is really being able to make sense of the concepts behind the operations. So then if I forget a memorized fact, I can go back to the concept and I have a strategy to getting that answer because I know what's going on in that idea. What if it was multiplication? So I'm a firm believer that math tools unlock abstract math concepts for most students, adults and children, as they provide a visual, hands-on, kinesthetic approach to understanding the math standards. We are asked to teach in a way that is different than we were taught. So we need to be gentle with ourselves. We're on a journey. I'm ecstatic about this though, because I recognize that for most students, having the opportunity to work with math tools and manipulatives and multiple representations is going to unlock the understanding of mathematics for them, and they are going to go on to high levels of math. Here are the top 5 teacher comments that we often get from teachers on why they don't provide math tools. Number 1, we don't have time. Number 2, I don't know how and why to use them. Number 3, my students can't handle it. Number 4, I didn't learn that way, so why should my students? After all, I did fine. Number 5, they can't use the math tools on the end of year state test. Okay, let's talk about these just for a moment. Number 1, we don't have the time. Our gentle response to this is, how can you not take the time for real learning and understanding? It is true that progressing through that CRA model, that concrete, the representational, and the abstract, it's going to take some time. But let's remember what the benefits are. Real learning is going to take place. So when students enter the next year of elementary school, they don't have to start over at the beginning and relearn last year because they didn't really understand what they were doing. They had, because you gave them that opportunity, a real understanding of the concepts from that grade level the year before, so they can just keep building. For number 2, I don't know how and why to use them. Well, hopefully watching this math workshop and others will help you with that. And remember, we're going to be gentle on ourselves because we're all on a journey. Number 3, my students can't handle it. We're going to provide a slide next that has tips for successful implementation. Number 4, I didn't learn that way. And our gentle response to that one is, well, research shows that most people learn best through tactile, hands-on, and visual experiences and representations. And the last one, they can't use the math tools on the end of year test. Well, that's true in most cases. But because they use that math tool or math tools during the year, they have internalized their learning. So we have found that whatever assessment they take at the end of the year, and perhaps, probably most likely, they are not going to be using a tool, a manipulative on that test. But because they've really learned that the standards and the concepts for that grade level, they're going to do well on that assessment. and maybe they will sketch or do a drawing. Remember, Mr. Fletcher said in the video that first we're going to have the concrete or hands-on, but we don't want students always using concrete. We've got to move them along to that representational model. So on an assessment, if I have some scratch paper, even if I'm taking it on a computer, I have some scratch paper, I can sketch out that array or that area model. Or maybe I've moved on to the abstract level. So those are some ideas for you. Here are some tips for successful implementation of math tools. Give explore time every time, okay? So we recommend that if you're going to be using inch tiles one day or pattern blocks another day, give the class a few minutes, and we mean probably just about 2. Set a timer and pass out the manipulative and say, all right, kids, explain to them the structure. This is your explore time. You're going to have 2 minutes, and they can touch the tool, feel the tool, see what it does, explore with the tool for 2 minutes. And then at the end of the 2 minutes, you tell them, okay, now we're going to use it as a math tool. The next tip, setting clear expectations. All right, class, we're going to be using these geoboards and rubber bands today. This is how you can use the tool. This is how you will not use the tool. And I am explicit with my students in telling them rubber bands will not go flying across the room. If they do, for the student who chooses that behavior, they have lost the privilege of using that tool, and they will simply have to watch their peers. Students don't like that. So usually setting them up for success, sharing how this tool can be used and will be used and how it will not be used. So setting those clear expectations usually works out well. Modeling usage. This is how we're going to use it. And consider your storage. And of course, that has a lot of factors to it. Your budget, your space, what works best for you? Do you want each student to have their own math toolkit where there's a variety of tools that they could choose from in their toolkit to solve various problems? It could even be a teacher helper's job to swap out however often you want the tools that are available in those toolkits? Or would it work better for you to have plastic bins in a specific spot in your classroom where when it's time to use that math tool, you pull it out and maybe there's enough of those bins for each table group, or maybe you have baggies inside the bins for table groups, baggies. So you got to think about what works best for you. I've seen a lot of great different ideas, but it's based on the teacher's budget and space. So let's explore how arrays and area model for multiplication can bring to life the abstract concept of multiplication. In the example on the slide in red, we're seeing 10 rows of 3, which equals 30. Or if we shift our head or just imagine the grid shifting, we can see 3 rows of 10, also 30. Same thing with the purple example. We can see 4 rows of 2 equaling 8, or if we turn our head, we can see 2 rows of 4. Same thing with the green example. We can see 4 rows of 7 equaling 28, or 7 rows of 4. We could also link this back to second grade math and find the repeated addition. In the green example, 7 plus 7 plus 7 plus 7. I could even put 2 of those 7s together, 14, the other 2 7s together, another 14, put them together, 28. And then the last example, I can see 4 rows of 4 equaling 16. These are great examples of how we can first use inch tiles. So physical inch tiles come in a variety of colors. They could be foam, they could be plastic. Then we can, after a while, move away from the inch tiles and move to grid paper. And students can be doing some shading. After that, students could just do a sketch or a quick drawing to represent their array or their area model. And then eventually they'll just you should move them along to the abstract. So just having the equation. So 4 times 7 is 28. Let's explore how arrays and area model for division can bring to life the abstract concept of division. In this example, we're showing with the red circles that there are 3 rows of 4 in the whole group of 12. We can divide those 12 red circles into 3 rows of 4 circles. So here on this slide, we have examples you can see of physical inch tiles. Then we have pictorial representations of the inch tiles. So the top example shows multiplication, 4 rows of 5, 4 times 5 equals 20. The bottom example is showing division, 8 divided by 4 equals 2. So inch tiles are a must in 3rd grade. Look at all the benefits of using inch tiles. Then, as I mentioned, you want to, at some point, move away from using the concrete representation and move to representational approach. That might be using grid paper, or students might be sketching and drawing. Look at all these benefits of using grid paper. So we know the properties of operations have been showing up in some of the standards, and we're going to explore the standards more. Do you remember learning about the properties of operations? I think I learned about them in 6th grade. I learned about their names, but honestly, I don't really think I understood what they were about. And I probably didn't remember their names for very long. But with today's math standards, the properties of operations actually show up in elementary school. And it's not so important that students know the actual names. The important part is that students understand what's going on within the properties of operations, that they understand how these can be used to support strategies to helping them with addition or subtraction, or we're going to be looking at multiplication and division. So how about we take a little quiz? We're going to say, do you know the strategy? Or can you guess the operation? Okay, let's try it. Here we go. What property is this? Did you guess the identity property? The idea that the product of any number and 1 is that number? Here's a visual representation. So 4 groups of 1 equal 4. Let's look at another one. Can you guess the property? This is an example of the 0 property. The product of any number and 0 is 0. Let's look at a visual representation modeling that. Oh, there we go. 4 groups of 0, 4 groups of nothing. There's nothing in the groups. That's nothing. 0. Let's try another one. Can you guess the property? Did you guess the associative property? You can group factors in different ways and still get the same product. Take a moment and digest this visual example on the slide, noticing how by using an image, we can make sense of the abstract numbers and symbols. Guess the property. Did you guess the commutative property? When you change the order of the factors, the product stays the same. Again, look at how this visual really supports understanding this property. We just have to turn our head or rotate our model. Here's another one. Guess the property. Multiplying a sum by a number is the same as multiplying each add-in by the number and then adding the products. That distributive property. Check out this example. Here is a third grade math standard. Apply properties of operations as strategies to multiply and divide. I'll let you look at the examples. So again, the important part is not that students necessarily can name the properties, though that definitely can't hurt, and that gives us a common language, and we can talk about how we used strategies of the properties of operations. But really, in third grade, the important part is that students understand these examples and how the mathematics and the examples can help us to solve problems. Let's explore this third grade multiplication standard. Interpret products and whole numbers. Oh, sorry, I read that wrong. Interpret products of whole numbers. For example, interpret 5 times 7 as a total number of objects in 5 groups of 7 objects each. For example, describe a context in which a total number of objects can be expressed as 5 times 7. So here's the context. 5 buses had 7 students in each, for a total of 35 students. Let's explore this third grade division standard. Interpret whole number quotients of whole numbers. For example, interpret 56 divided by 8 as the number of objects in each share when 56 objects are partitioned equally into 8 shares, or as a number of shares when 56 objects are partitioned into equal shares of 8 objects. For example, describe a context in which a number of shares or a number of groups can be expressed as 56 divided by 8. So they're flipping back and forth. Remember that hamburger example from before? The two things we were considering were how many groups of the hamburgers and how many were in each group. So there's two ways to think about division. So 56 students rode on 8 buses. That's 7 students on each bus. So another way to flip this could have been 56 students went on a field trip. There were 7 students on each bus. How many buses were there? Let's look at another one. Use multiplication within 100 to solve word problems in situations involving equal groups, arrays, and measurement quantities. For example, by using drawings and equations with a symbol for the unknown number to represent the problem. An octopus has 8 legs. How many legs are there with 4 octopuses? Side note, I did Google that. I really thought it was octopi, but according to my Google search, it said octopuses. It feels weird to say that. 8 times 4 equals what? Look at my picture. 8 times 4 equals 36. $32. I just realized a mistake. Oh my goodness. 32. Sorry about that, because I knew my picture showed 32. Oh my goodness. It's a typo. 32. Use division within 100 to solve word problems in situations involving equal groups, arrays, and measurement quantities by using drawings, equations with a symbol for the unknown number to represent the problem. Here I have my 32 correct. There were 32 octopus legs. How many octopuses were there? 32 divided by 8 equals 4. Do you see my 4 groups? To support the CRA model and the third grade math standards, we recommend inviting students to solve the math problems you provide for them using manipulatives, pictures, words, and numbers. Determine the unknown whole number in a multiplication or division equation relating three whole numbers. For example, determine the unknown number that makes the equation true in each of the equations. Notice how the second equation is different from the first and the third. You want to present problems where the answer's first, and then there's the equal sign, and then you're trying to figure out something in the equation. You don't always want to have the answer at the end, if that makes sense, because it's still the second circled equation is still a correct way mathematically. And that's what we're highlighting, that that equal sign represents a balance of the equation. So you want to present problems both ways. Understand division as an unknown factor problem. For example, find 32 divided by 8 by finding the number that makes 32 when multiplied by 8. So look at how in third grade, we really want students to understand that inverse relationship between multiplication and division. So if I don't know 32 divided by 8, but I know there's a relationship to multiplication, and I know that 8 times 4 is 32, I can find the answer. Look at this third grade math standard. Fluently multiply and divide within 100 using strategies such as the relationship between multiplication and division. For example, knowing that 8 times 5 is 40, one knows that 40 divided by 5 is 8. Or fluently multiply and divide within 100 using those properties of operations that we looked at earlier. By the end of third grade, know from memory all products of two one-digit numbers. So that's up to 9 times 9. Let's focus on that word fluently that was on that slide before, which is now on the top of this slide. Fluently multiply and divide within 100. In mathematics, we talk about that the word fluently means with efficiency, with flexibility, and with accuracy. Let's take a moment to define those. What is efficiency? In mathematics, efficiency is solving a problem in a reasonable amount of time by selecting an appropriate strategy and by readily implementing the strategy, so doing the strategy. This is not about time tests at all. It is not that. This is knowing that there's a multiple ways I can solve the problem, and which way is an efficient way that I can get to the solution pretty quickly. Again, not time test, but just being efficient. Flexibility. That is knowing multiple procedures or knowing multiple ways to solve a problem and applying or adapting strategies to solve procedural problems. So it's recognizing that, okay, I have to solve this problem. I can be flexible in my thinking. What would be a good way to solve that problem? So it's not just having one way and I'm just a little robot trying to do this. It's more than that. It's more sophisticated. It's thinking about, I got to be flexible in my thinking. What's the best way to solve this problem? And accuracy. That means correctly solving a procedure. So we're being accurate. Let's watch another great video, this one on division by Graham Fletcher again. And let's remember to keep that CRA model, that concrete, representational, and abstract in mind as we watch it. And again, we're just going to watch up through the end of third grade, and then we'll stop it.
A man who works hard sweats hard.
Old Spice rider fights sweat, so coach thought I was slacking. So
Understanding we just saw should have been happening in third grade.
Let's back this back up. There we go.
Of all the things that students must learn by the time they leave elementary school, division might be one of the toughest. So here we look to tackle the progression of division, and it starts in third grade. So take this for example, 12 divided by 4. Let's see what happens. Well, we have two completely different models. And what this says is that the context, the story of the problem, plays a large part in developing students' conceptual understanding. In one, we have 12 bears with 4 in each group, which gives us 3 groups, and 12 bears shared with 4 friends, which leaves us 3 with each group. One model, well, that's measurement or repeated subtraction. The other is fair share, which I think we're all pretty familiar with. In one example, we have the group is unknown, and in the other, the size of the group is unknown. As students begin to develop their understanding of division, they probably begin to really rely on this fair share model. But 54, that's going to take a long time using fair share. So we need to put students in a place where they begin to become more flexible and efficient thinkers. So they might begin, instead of doing 1 by 1, they might say, I'm going to take out 5 and put 5 in each group to start. Then with their remaining pieces, they might put 2 in each group, and so on. So within each group of 6, they've placed a group of 5, a group of 2, and another group of 2. So when you take 54 and you divide it into 6 groups, you get 9 in each group. Now here students are making the connection between the concrete, the representation, and the abstract. And you know what? It all makes sense because students are building these pieces conceptually. As students begin to explore again in third grade, they deal with quotients which are greater than 10. Here students might begin to explore the idea of division with base 10 blocks. So they'll start with 72, and instead of putting it into 3 groups, they'll put it into 3 rows. They'll start by placing 10 in each row, then 10 in each row, and then they have that 10, and in order to place it in each row, they need to decompose it, make a fair trade. So you can see that when we take 72 and we divide it into 3 rows, we have 24 in each row. And then we want to make that connection from the concrete with the base 10 blocks to the representation. And how do we record our representation in a written expression? And some students might begin to collectively group their 10s, and that's where the 20 came from. The best part about this is that students are making a connection back to multiplication by using the distributive property, and they're seeing it visually. In 4th grade, yeah, that's right.
Another great video. Oh, I could watch that one over and over. Again, I think I keep getting something different out of it. So let's continue on with exploring the math standards for third grade. Identify arithmetic patterns, including patterns in the addition table or multiplication table, and explain them using those properties of operations. For example, observe that 4 times a number is always even, and explain why 4 times a number can be decomposed into 2 equal addends. Wow, giving our students opportunities to explore the addition table and to explore the multiplication chart can be very powerful in their unlocking the multitude of patterns that are underlaying on these charts. We've talked about the importance of students understanding the relationship between addition and multiplication, and the relationship between multiplication and division. Additionally, it's important that we provide opportunities for our students to learn math concepts with a balance of conceptual understanding and procedural knowledge. Let's take a moment and let's watch a video which talks about the importance of this balance of conceptual understanding and procedural knowledge.
Let's learn about conceptual understanding and procedural fluency in math. Most math standards and programs state that students should learn math with a balanced approach, encompassing both conceptual and procedural understanding to achieve true mathematical proficiency. We want our students to be mathematically proficient and be terrific real-life problem solvers and critical thinkers who are financially literate. You can think of conceptual understanding as the why and procedural understanding as the how. Conceptual understanding involves grasping the underlying principles, relationships, connections, and reasoning behind mathematical concepts. It's about understanding why a procedure works, not just what it does or how to perform an operation or algorithm. An example of conceptual understanding would be knowing that 10 can be decomposed or broken apart in a variety of ways. We can make 10 with 7 and 3. 5 and 5 also can make up 10. We can also make 10 with 9 and 1 or 6 and 4. 10 can be broken apart or decomposed in a variety of ways. We can be flexible in thinking about how to compose 10. An example of procedural fluency with 10 would be knowing that 6 and 4 make 10 because we can add on 4 to the 6 using the counting on strategy. 7, 8, 9, 10. Another example of conceptual understanding in math is knowing that multiplication is repeated addition. Seeing the connection or relationship between multiplication and addition. If I want to know the product of 5 times 5, I can add 5 groups of 5. 5, 10, 15, 20, 25. I could also use an array or area model to figure out the solution for 5 times 5. An example of procedural fluency within multiplication occurs when I memorize my multiplication facts. I know that 5 times 5 is 25 because I memorized it. That is procedural fluency. Remember that math standards and programs stress the importance of students learning math with focus on a deliberate balance of conceptual and procedural knowledge. Why? If we only learn procedurally, memorizing facts, and using algorithms like the standard multiplication algorithm or the long division algorithm, and we don't understand the foundational concepts of multiplication or division, then when we forget those memorized facts, which most likely most of us will forget, then we don't have a pathway to figuring out the solution, or we make mistakes when using the steps in the algorithm to solve the problem because we didn't truly understand why we were doing what we were doing. If I forget that 6 times 7 is 42, which I might realistically forget if I only learned procedurally by memorizing my facts, but not understanding what multiplication is, then I'm out of luck. But if I learned conceptually all about multiplication and understand the concept of multiplication, then when I forget that multiplication fact of 6 times 7, I can use the conceptual reasoning that I had learned to figure out the answer. I could think, well, I don't recall 6 times 7, but I remember that 6 times 6 is 36, and I know I just need one more group of 6 to find the answer. So 36 plus 6 equals 42. There's my 6 groups of 7. Or I could sketch an array of 6 rows of 7 squares and calculate my product as 42 using a visual approach. Conceptual understanding helps students learn more flexibly and retain knowledge better. Which should come first? Conceptual or procedural knowledge? We want to first help our students develop conceptual understanding in mathematics, which lays the foundation for success with procedural fluency. So again, our students grow into highly proficient mathematicians who can problem solve and be critical thinkers. Why does this balance of conceptual and procedural knowledge in mathematics matter? Deep learning. A balanced approach fosters deeper and most lasting mathematical understanding. Flexibility. Students can apply their knowledge to various problems and contexts. Problem solving. Students can better reason appropriate strategies. How do we achieve this balance? Start with concepts. Introduce concepts before procedures, allowing students to develop a solid foundation. Connect concepts and procedures. Show how procedures are derived from and relate to underlying concepts. Provide opportunities for practice. Offer ample opportunities for students to practice procedures in various contexts. Encourage reasoning and explanations. Ask students to explain their reasoning and justify their answers. Use visuals and manipulatives. Employ visual aids and concrete materials to help students understand concepts.
Welcome back. So let's move on to the third grade fraction standards. Let's watch our last Graham Fletcher video on fractions, which I think will support our understanding about what third graders are expected to understand about fractions.
Responding to emails takes time, but not with Grammarly. In a few clicks, Grammarly's generative AI drafts professional
Fractions. The very sound of the word, well, it kind of freaks most of us out. So here, I'm going to take a stab at explaining the progression of fractions. And it begins in first grade. And it starts with a crazy word, partition. And I think that students should be able to use that word as well. So in first grade, students should be able to partition squares and rectangles into halves and quarters, which can also be represented or called fourths. The vocabulary development here is the biggest piece in first grade. So they could also say a quarter of, a fourth of, or a half of. In second grade, students build on their understanding of halves, quarters, and fourths, and they're introduced to the idea of thirds. Again, they should be using that term, thirds or a third of. When students leave second grade, a big piece of understanding they should leave with is even though shapes can appear different, they actually can have the same size. So this brings us to third grade. It's a really big year for the development of fractions because here students are beginning to really truly develop that meaning of a fraction. And it's the first time that students see fractions written as a symbol. So even though we're talking about symbols, we really need to place our emphasis as teachers on the visual representation of fractions. So how can we do that? Well, one way we can do that is by creating a length model. Here you see that we've taken a strip of paper and folded it up into 4 parts. Another way, which isn't really explored in third grade, is the use of a set model. Here in this set model, you can see that 3/4 of the bears are green. And the last way that we can represent fractions is one that I think we're all pretty much familiar with, and that's the area model. Here, 3/4 of our square is yellow. As students are building this understanding, we need to make a connection back to their understanding of what they have with whole numbers. So just as whole numbers, take for example this number 4, is built from units of 1, fractions, in this case 3/4, is built from 3/1/4, a fourth plus a fourth plus a fourth. Big understanding here. Let's go back to that length model. Well, that length model is a really powerful tool because it helps build students' understanding, which can also be done through a number line. Here's another number line. What number is the question mark? Here, let me help. Wait a minute, that's greater than 1. Well, in third grade, students need to see that fractions can also represent numbers greater than 1. It's the sum of unit fractions. So we might want to get students to begin counting with fractions. 1/3, 2/3, 1, 4/3, 5/3, 2. Let's get our students counting by fractions. Counting circles are a great tool to get students understanding and seeing the sum of unit fractions and that repetition and the structure of numbers. So as students begin to learn dividing in parts of a whole and partitioning up shapes, they begin to explore this idea of equivalent fractions. So here we're going to take 4 lines and we're going to divide them up. We're going to partition them all into equal parts. And as we partition them all up into equal parts, we begin to see that, hey, some of these line up a little bit. Here students are beginning to explore the idea of equivalent fractions. So 1/2 is equal to 2/4, which is equal to 3/6, which is really the same as 4/8. The big piece here that students really need to see and we need to push and promote is that the size of the whole doesn't change, just the size of the parts do. But even though we're talking about fractions, students need to also understand that whole numbers can also be written as fractions. Take, for example, the number 1. Here's 3 ways that we can represent that number 1. As students begin to build that understanding and they continue to build their understanding, we compare fractions. Here, 1/4 is greater than a half. Now you might be thinking I'm crazy, but I'm not. See, 1/4 is, yep, 1/4 is greater than a half. It comes back to this understanding that students need to see that we have to be talking about the same size whole. So let's compare these two fractions, 3/4 and 5/4. Well, here we see that a quarter is a rhombus. So if we have 3 1/4, that's actually less than 5 1/4. And that's a common denominator strategy. Another way we can compare fractions is if we have a common numerator. Here we have 1 as a common numerator. Yeah, common numerator. It doesn't quite sound right, but here students have this understanding and should be building this understanding of a common denominator and common numerator. Here students can see that 1/6 is actually a smaller piece than 1/3, and therefore it's less.
Another great video. Didn't you love that? Another one that every time I watch it, I get something new out of it. All right, let's continue. Overview of fractions in 3rd grade. So the big idea is students are really developing an understanding of fractions as numbers. All right, here's a lot of language, but we're going to make sense of this. Students develop an understanding of fractions, beginning with unit fractions. 1/3, 1/5, 1/10, 1/6. Students view fractions in general as being built out of unit fractions. And they use fractions along with visual fraction models to represent parts of a whole. Students understand that the size of the fractional part is relative to the size of the whole. For example, 1/2 of the paint in a small bucket could be less paint than 1/3 of the paint in a larger bucket. But 1/3 of a ribbon is longer than 1/5 of the same ribbon, because when the ribbon is divided into 3 equal parts, the parts are longer when the ribbon is divided, are longer than when the ribbon is divided into 3 equal parts. 5 parts, sorry. Students are able to use fractions to represent numbers equal to, less than, and greater than 1. They solve problems that involve comparing fractions by using visual fraction models and strategies based on noticing equal numerators or denominators. Mr. Fletcher mentioned all of those in his video. So understanding that a fraction as a number on the number line shows up for the first time in 3rd grade, representing fractions on a number line diagram. This is a big one for 3rd graders. The number line can be a very powerful tool for helping students recognize the distance of the various fractions on the number line. We can have a strong visual for equivalent fractions. For example, on the slide, look at all the equivalent fractions equivalent to a half. I can just look right down on the middle of the slide. 2/4, 3/6, 4/8. In 3rd grade, number lines can be used to visually represent numbers, fractions, and they can be used to represent operations like addition, subtraction, multiplication. So they're very, very powerful tools. There's open number lines as well. Definitely want to be modeling for your students how you can use number lines to do work with operations and also understanding fractions. Here is a 3rd grade fraction standard. Explain equivalence of fractions in special cases and compare fractions by reasoning about their size. So strategy 1, comparing unit fractions. 1/10 is less than 1/3 because 10 pieces are much smaller than 3 pieces of the whole. And we're looking at these fractional parts in comparison to their own whole, if that makes sense. So I'm looking at that pink slice of 1/10 in comparison to its whole. And for the green example, I'm looking at that 1/3 in comparison to its whole. So though these circles are different sizes, but we're comparing the piece to its whole. So strategy 1 is a great strategy, comparing by using the strategy of unit fractions. So I'm thinking to myself, 1/10, wow, that's going to be a small part because that pizza or pie or whatever I want to envision was cut into 10 pieces. And 1/3, wow, that pizza or pie or whatever was cut into 3 pieces. So those pieces are going to be much larger. So 1/10 is smaller because the tenths are smaller pieces, and it was 1 out of the 10. Let's look at another strategy for the same standard. Strategy 2, comparing fractions with common numerators. So Mr. Fletcher talked about this one too. So 2/4, my first image, I'm comparing with 2/6, my second image. And 2/4 is more than 2/6 because 2 out of 4 is more than 2 out of 6. 2 out of 4 is actually half, and I can see that 2/6 is less than half. It would have taken 3 of those pieces to make half. So when I have the same numerator, I can compare based on what my denominator is and that relationship between the two. Here's another great strategy for the same standard, strategy 3. Compare fractions with common denominators. Mr. Fletcher talked about this one too. So here, both images are sixths. Both of those circles are cut into 6 pieces. The first one is 4/6, and the second one is 1/6. But I can see that 4/6 is more than 1/6 because 4 out of 6 is more than 1 out of 6. So when I have a common numerator, it's quite easy to compare the sizes. Here's strategy 4. Compare fractions that are 1 unit from 1 whole. So in the red example, that is 3/4. And in the pink, or I'm not pink, yellow example is 5/6. They both have 1 unit missing to get them to a whole. But I can see that 5/6 is larger than 3/4 because sixths are smaller. So that one little bit to get me to 6/6 is a smaller piece. And fourths are larger, so that 1/4 is going to be a larger amount. Strategy 5, comparing fractions to a half. So using that benchmark of a half. So my first model on the screen, the purple, is 2/6, and my second example is 4/6. I can use a benchmark of half and say to myself, well, 2/6 is 1/6 less than a half. I can visually just imagine one more of the purple pieces colored in, and I can see that's a half. So it's 1/6 away from a half. And I can see with the pink model that 4/6 is one more than a half. I can just kind of shade out one piece of that pink piece and see that would be a half without it. That would be 3/6. So I can see that the first picture is one piece less than a half. So 2/6 is 1/6 less than a half. And I can see in my pink example that 4/6 is 1/6 more than a half because 3/6 is a half. So I can see that 4/6 is larger than 2/6 because it is more than a half. Let's look for a moment at some of our favorite fraction models or math tools that we want to provide for our students. All right, one of our absolute favorites are these. So a lot of different companies make fraction strips or fraction bars, and most often they're labeled. So they're printed, they're pre-printed with the name of the fraction amount. And so the benefit of using fraction strips to support students' understanding of the area or region model is that students can compare the sizes. What I love about what you see on the screen, this is the Marilyn Burns fraction kit. You can get it at Heinemann.com. They produce these and sell these. What I love about this kit is what you're seeing on the screen are the magnetic strips, and they can be cut apart so that you can compare the sides. So they can stick on the side of a file cabinet, or if you have a whiteboard that's magnetic, and they're very sturdy, and they're about this long each. What I love about it is when you order it, you also get within the kit, you get 30 sets of colored strips that match the same colors you see on the magnets. And students, you lead them through lessons, which the lessons are in the fraction kit. They make their own fraction strip kit. Now, it does take time. It does take time, but real learning takes time. And not only do students make their own fraction kit by cutting, and you're going to lead them through how to fold, how many pieces do we have, you're going to have them label their pieces. And a big tip, have them write their initials on the back of each of their pieces so that inevitably when the pieces fall on the floor, which they might, the class knows whose piece it is. Additionally, within that fraction kit, you're going to get fraction games that students can play using their fraction kit, and you get fraction dice, and you get a long baggie for each child to put their pieces into. So, hands down, one of our favorite tools to use. So again, that's a Marilyn Burns fraction kit from Heinemann.com. All right, the next one from Cuisenaire rods. Oh, we love these too. These, the benefit of Cuisenaire rods is that they can be used to also represent that area region model. They're wooden, and what's so wonderful about them is they're not labeled. So there's so much thinking your students could do. So for example, if I just look at the screen and I say, let's pretend that the red rod equals 1 whole, how much does the white rod equal? And so students would line up the two little whites, because you get multiples of the rods, and see that it takes 2 whites to cover the same region or area as the red. So the whites would represent 1/2. There's just a lot of different thinking that students can do. Conversely, I could say, well, let's pretend the white rod is equal to 1. How much is the red rod? So that is 2. So there's just a lot of flexibility and a lot of thinking that can go on with the Cuisenaire rods. Love them so much. We also love pattern blocks. Pattern blocks are also a great tool for working with fractions. So for example, I could say, let's pretend for our purposes right now that the yellow hexagon equals 1 whole. What would we call the trapezoid, the red trapezoid? And so you would have students discover and they can place the red trapezoid on top of the yellow hexagon, and 2 actually fit perfectly. So that means 1 would be 1/2. So there's a lot of different thinking you can do there. You could say, well, the red trapezoid now is equal to 1 whole. What would we name a green triangle? And students would explore and they would see that 3 green triangles fits perfectly on top of the red trapezoid. And so we'd call it 1/3. So again, I love pattern blocks like I love Cuisinart rods because they're not pre-printed with a label. So we can be flexible in our thinking and our discovery. Measuring cups can be a great tool to use. And of course, they're real life with using baking and cooking, as well as a clock can be a great tool for learning about fractions. If we look at 60 minutes in an hour, what fractional part would 15 minutes be? All right, you should have received a slide deck full of math routines for your grade level for 3rd grade. We love kicking off math class with a 5 to 15-minute math routine, kind of to warm up the math juices, wake up our brain. And as you see on the slide, for this math workshop, in the sample slide deck that you received math routines of which does not belong, array images, visual patterns, and quick images. So we have a video for you which highlights the math routine of quick images, which does not belong, array images, and visual patterns. So we'd like to play it for you now because all those routines, though they have a lot in common, they all have some specialness to the routine. So we want to share that with you right now. In this math workshop, we will examine math routines as a key tool in our math toolbox of strategies to support our students. We will share what they are, why we should facilitate them, when to facilitate them, where and how. Whether you are an educator new to teaching math, a homeschool parent teaching your young mathematician, or a parent interested in supporting your child, or an experienced math teacher, our hope is that this math workshop will provide support and guidance for you as you teach your children mathematics. What are math routines? Math routines are a daily 5 to 15-minute routine. They are structured, repeatable activities in mathematics classrooms that provide a framework for engaging students in thinking, reasoning, and communication. They offer a predictable structure that supports both teachers and students, promoting deeper mathematical understanding and student agency. The teacher's role is to provide the math routine and to facilitate the discussion. Teachers do a lot of listening and learning about their students' mathematical understanding. The student's role in math routines is to think, reason, share, and learn from each other. They're honestly our favorite part of math class. This comes from educators, students, and myself. What are some math routines? Well, just to name a few, number talks, subitizing, quick images, which doesn't belong, tell me all you can, visual patterns, array images, same and different, guess the rule, and share your solution. And there's more, but those are just to name some. When should a teacher add math routines to their schedule? Math routines are a great way to warm up students' mathematical brains at the beginning of math class. They're naturally a great transition because students love to engage in them. I remember a 1st grade classroom that I was coaching in a while back, and the 1st grade teacher had students meet at the rug right after recess or break for their math routine time. And I was just so impressed with how eager the students were to get back inside, get settled quietly on the rug. They were so excited to participate in their math routine. Conversely, math routines can also be implemented at the conclusion of math class as an exit ticket. Students could record their responses in a math journal, on a post-it note, on a note card, on an individual whiteboard, or simply do a turn and talk with a partner. Maybe there's an odd 10 minutes in your class schedule for the day in between specials or subjects where a math routine would be perfect. Honestly, there's no wrong time to engage your students in a 5 to 15-minute math routine. Parents even love to see math routines modeled with them themselves at back to school nights. Where to engage your students with math routines? The answer lies in your particular situation and space. Educators take their physical space, their classroom, into consideration, whether they're gifted to have a large whiteboard projector, and if they have a rug where students can meet as a mathematical community, knowing they're just going to be there 5 to 15 minutes. So it's not too long, short and sweet. Additionally, teachers may want to consider what math tools would be valuable to be posted near that area, wherever they're going to have, where they're going to facilitate their math routine. For example, in kindergarten, I've seen teachers, of course, kindergarten teachers always have a rug. They'll have a large number path posted easily within view of the kindergartner's eyes to support their time in the math routine. Also, in second grade classrooms, I've seen teachers post a large 100 chart nearby the area where the students were engaged in math routines. So I know teachers just consider what visual representations or models might support my students' thinking and being successful during this math routine. Educators want to consider how where they facilitate the math routine impacts their students' ability for communication. Because we really want to foster students' thinking and as they're sharing with their classmates and listening to their classmates. So sometimes teachers don't want their students back at their desks where they're more spread out and where they're more likely to fiddle with things inside their desk and not give their full attention to the discussion that's taking place during the math routine. But honestly, teachers really have to think about their space and what works best. How to facilitate math routines. Well, there are nuances within particular math routines. We have more math workshop videos on the various math routines that we have on our website, themathworkshop.net. So, for example, with quick images, which are in essence a type of number talk, we only show the image to students for about 3 seconds, and then we hide the image. And the reason for this is because we're trying to gently influence our students not to count the items on the screen, but to see the groups of items. This is called subitizing. Each math routine has its own slight nuance, but in a nutshell, all math routines should be short and sweet. They should happen daily. That's why they're powerful, because the benefits collect over time for students and their understanding. And now let's look at some examples of some of the math routines that we can provide for our students. This is an example of a quick image. So you see dots. Students would be shown these dots for about 3 seconds. So you're seeing them for a lot longer. And they would be asked to consider 2 questions. First, how many do you see? And then, how did you see them? And again, we have more math workshop videos that dig deeper into each math routine, but this is just an overview. So some students might say, I saw 4 and 4 more, and I knew that made 8. So the teacher is the one doing the recording, listening to students, and the teacher might ask, who else saw it that way? And sometimes teachers teach their students the sign language, which means me also or me too. essentially, I saw it that way too. It's a quiet way, for a nonverbal way, that the teacher can look around and see who else saw the 4 and 4. But then the teacher asks a wonderful follow-up question. Who saw it another way? I love that question because it's really a positive supposition that there are other ways to decompose this 8. So by asking it as who saw it another way, it's really inviting students to go, oh, there must be other ways. So then maybe another student might say, oh, I saw 2 and 2 and 2 and 2, and that makes 8. And again, the teacher is the one who's quickly recording, possibly, if the teacher makes that decision. Probably an early beginning of kindergarten, teacher might not be recording yet. They're just warming up the kids, getting used to this routine. Definitely later in kindergarten, the teacher's going to be recording these, the groupings, and recording with equations and the numbers. And upper grades are probably, it's more, they should be doing that too. And again, the teacher's going to say who saw it that way, and other kids might be doing the silent sign language for me too that you would teach the class. And again, the teacher's going to ask that follow-up question, who saw it another way? Or even if no one says they saw it another way, you could say, push them and say, can you push yourself right now to see it another way? And still some other students might say, well, I knew it was 8 because 1 and 1 make 2, and 3 and 3 make 6, and 2 and 6 make 8. And depending on the age of the students, again, teacher may want to record that corresponding equation and name the strategy. So that student was adding by doubles. So by naming the strategies, we can empower our students to now have this common language, because the 1 and 1 make 2, 3 and 3, 6, those are doubles. And knowing the names of strategies can be really powerful for students to be able to make connections with each other and be able to use that strategy again. So the superpower of quick images, and quick images honestly can be used K through adulthood. The superpower of quick images is that students are seeing all the ways that a number, and in this example, it was 8, can be decomposed or broken apart. And on this slide, we're seeing 3 examples from students, and there are others, but we're looking at 3 examples. And this is a very important idea, that this subitizing, where students are seeing groups within a larger number, what sets make up that number, can make up that number. This actually begins to lay the foundation for success later in algebra. Now, it's really important that the dots, for using dot images for our quick images, that they're very strategically placed in purposeful ways. And there are resources out there for you on what dot arrangements seem to elicit groupings. So we do have more information on our website about this. So I would encourage you to explore that if these dot images, these quick images, are new to you. Let's look at another math routine. This one's called Which Does Not Belong. And in this math routine, the teacher usually shares a collection of 4 items. It could be numbers, shapes, photos, or pictures, sometimes words, and asks the students which does not belong, and asks the students to think about why. Why does it not belong? So here's an example of a which does not belong. It would be appropriate for kindergarten, maybe first graders who need to revisit some early numeracy work, or, let's be honest, there's going to be other students in other grades that perhaps for a multitude of reasons, some foundational mathematical ideas were not in place, that this would be beneficial to continue to work on. I'm going to pause so you can consider, out of those 4 10 frames, which does not belong and why. Some students might say that the top left 10 frame doesn't belong because the 5 red counters spill over into the 2 rows. So we see 4 and 1. Whereas in all of the other examples, the 5 is in a consecutive row. Some other students might say that the bottom right example of the 10 frame is the one that doesn't belong because all of the red counters are on the bottom row. And for the other examples, mostly the red counters are on the top row. Both responses are acceptable. The beauty of all math routines is that the thinking and the reasoning comes from the students. If you don't get responses that you think are really digging that deep, revisit the image later, another week, another month, come back to it another time. This is not really a time for you to teach or to show your thinking, because honestly, I think we've seen as educators that doesn't stick with kids. So revisit this another time, and maybe your kids are further along in their thinking, and then they might see what you were hoping in your mind they would see. In a lot of examples of which does not belong from various educational resources, you're going to see an A, B, C, D labeling. We intentionally did not label our collection of which does not belong because we strategically wanted students using positional words, which are in the kindergarten math standards, next to, above, below. So we want to give students that opportunity to use that kind of language. So they might say the top left, the top row, the bottom right, and so on. Here's another example of the math routine which does not belong. Which one do you think doesn't belong? Did I give you enough time? These are pattern blocks. And as a side note, you're probably going to want to have, I would say, really for all, I would say K through 6 should have pattern blocks because they're foundational for kindergarten, first grade, second grade, for shapes, talking about different characteristics and attributes of shapes, but also fourth, fifth, and sixth grade can use pattern blocks to work with fractions. And if you watch our videos that we have on our website or on our YouTube channel, we have a math tools video for fourth, fifth, and sixth grade that touches on this. So which one did you think didn't belong? Oh, and one more side note is the graphics that I'm using on this slide, you can access for free on the Math Learning Center website. They have interactive tools, which are a great way to model the tools, these manipulatives you would have in your classroom. All right, let's get to the answers. So some students might say that the yellow hexagon on the bottom right corner doesn't belong because all of the other options are either a trapezoid, the red shape is a trapezoid, or they're making a trapezoid. The shapes are composed together to make a trapezoid. Other students might say that the green triangle and the blue rhombus in the top right doesn't belong because it's the only option that has 2 colors, whereas the other options just have 1 color represented. Both answers are completely appropriate, and students would be using reasoning to come to those conclusions, and there could be more answers. Those are just 2. Here's a 6th grade example for which does not belong. In this example, the pinkish purple rectangular array is the only choice that doesn't represent 9. The superpower of the which does not belong math routine is that the options we present to our students should have multiple answers. They don't always work out that way, but most often they do. And that's really the beauty of it. So that takes thoughtful consideration on our part to design problems where there's multiple opportunities for reasoning. Next up is array images. With this math routine, the students will be shown an image and asked to consider some questions. The teacher should consider if math tools like manipulatives or grid paper, maybe individual whiteboards, would that be supportive to students' thinking and exploration during this math routine? And it's going to depend on the image each time. Depending on the time frame, the teacher will also adjust the number of questions explored. They will invite students, either independently or with partners or in small groups, to generate equations that match images. And possibly, if there's time permitting, students could do a gallery walk, viewing different students' equations, or pass the paper to examine equations to compare the equations. The images in this routine, though, I wanted you to know, are not intended to be flashed like the quick images routine. So we're just going to look at them and keep them up and be comfortable with them and see them. With the array images math routine, we recommend educators use the look, think, talk strategy. And honestly, this can really be used throughout the day in a classroom with multiple situations. So look, show students an intriguing image and pose a mathematical question. Think, give students a chance to think. Talk, engage students in a discussion about the image and questions. Here are some array image questions that a teacher could consider. And again, it's based on the student's age, the image you're using, how much time you have. But here are some of the questions you could choose from. What do you notice and wonder? How many are there without counting? That's what we're really pushing to. Now, some students might be just comfortable at this point counting, so we don't make them feel bad or shame them for any reason for counting. But we want to gently try to highlight the strategies that come from students that don't involve counting. That's where we're going to hover and give a little more time and energy to, because again, it's related to the subitizing, seeing groups of within a larger group. We might ask, can you see it a different way? What equation would match the way you see it? Is there another equation that would match the way you see it? And here's even a bonus question. If a student presents an equation that another student didn't come up with, can you push yourself to see how their equation also matches the picture and how? So once you get in the swing of doing this math routine, you'll come up with other questions too as they relate to the image. Let's look at one of these images. Depending on the age of our students, we might ask, especially if this was kindergarten, first grade, second grade, we might start with, what do you notice? So really, we're just entering, base level. Everybody in the room can be engaged because every child is going to notice something. Hey, Miss Brewer, I noticed there are dogs. Oh, I think the dogs are sitting on stairs. So we just want every student to be initially, again, we're just starting baseline, engaged. So what do they notice? Then you might and we're going to do this pretty quickly. We're not going to spend a lot of time on the what do you notice. The follow-up question might be, what are you wondering? Is it one family that has all these dogs? Where do they sleep? How much do they eat? Okay, so just give them a little bit of time to have that natural curiosity. What are your wonderings? Then we might get to, how many do you see? How do you know that? And again, we're not flashing this image. We let them look at the image. What equation would match the way you see it? Some students might say, I see 8 steps with 2 dogs on each step. So 8 times 2 equals 16. Okay, that might be a 3rd grade class, 4th grade, 5th grade. Another student might say, I saw 2 dogs on each of the 8 steps. So 2 plus 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 2 equals 16. The teacher can write the corresponding equations, maybe on chart paper nearby, or if this is displayed on an interactive whiteboard where you have the ability to record equations, I would strongly recommend doing that. All right, let's look at another one. Here's another array image. The teacher might decide that providing individual whiteboards with dry erase pens might be beneficial for this example. So the teacher's going to pre-think, do my students, would they need something to have access to this problem? Students would probably notice that the top row has 4 rolled items, and each remaining row below that has +1, +1 more, +1 more. So essentially, we end up with an equation that is 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11. With this problem, students probably would benefit from some place to record their thinking. That's a lot of math to do, mental math in our head without keeping a record of it somehow. I'm not saying it couldn't be done, but it might. Having a place to record our thinking might really be beneficial and open up the range of students that are successful with this problem. A follow-up question could be asked if, again, depending on the age of the students and if we feel it's appropriate to challenge them that day. How many rolled items do you predict would be in the 10th row? Why? How did you figure it out? Here's another example of array images math routine. Notice the questions that could be presented for students to use with this image. So the superpower of the array images math routine is due to the nature of the questions, especially the first question on the slide, what do you notice and wonder? As I mentioned earlier, all students are going to be able to participate with that question, and it's going to initially get them engaged about the image. For this math workshop, let's examine one more math routine. Let's examine visual patterns. These are the visual pattern questions that teachers can choose to use. Some of them are similar to the last questions we just looked at. What do you notice? What do you wonder? What do you think you will see in the next step and why? That will make sense in a moment. Now that the next step is revealed, what do you think you will see next and why? How is the pattern changing? So let's look at an example. When using the visual patterns math routine, you will share with your students that they're going to be shown some steps in a pattern. Their job is to consider the questions that you choose to ask. So what do you notice? What do you wonder? And most importantly, the question we really want to hover around and have the most energy around is, what do you think you will see in the next step and why? We are looking at the first step in the pattern now. What do you think you will see in the next step and why? Here's the next step in the pattern. Does this represent what you predicted? What do you see happening from step 1 to step 2? How do you predict the pattern will grow for the third and final step? Here is the final step. Is this what you predicted? How has the pattern changed? Depending on the age of your students, they may be able to come up with a rule or statement on how the pattern is growing. You can challenge students to predict the next design. That would be the 4th step, or the 10th, or the 100th. So again, that's really age dependent design in this pattern. Here is the answer key. And in our examples that you can purchase from our website, we have the answer key for you for all of them. So in this growing pattern, step 1 has 4 blue squares, 1 purple square, and a total of 5 squares. Step 2 has 8 blue squares, 1 purple square, and 9 total squares. Step 3 has 12 blue squares, 1 purple square, and 13 total squares. So between the steps, we're seeing a +4, +4, +4. So the advanced rule for upper grade students would be, oh, sorry, I went too fast, 1 + 4n. Now, we do provide the answer key for you as the teacher, but I want you to hear me clearly. We're not suggesting you reveal the answers to the students. Again, the purpose of the math routine is to see what we get from students. So the answer key, it's not going to show up on a slide like this. I'm just doing this for this presentation. It will be in your notes that you will have, but it's just to help you facilitate the discussion if the discussion goes that way. Oh, Miss Brewer, I notice it's a +4 each time. And so you can have that information in the back of your head because you looked at the answer key, and you're going to be thinking about how am I going to record that? So maybe even drawing an arrow and doing +4, drawing an arrow +4. You, as the facilitator, you're going to be making those decisions on what should I record and how should I record it so that all my students in my class can get access into whichever student was sharing what they noticed. The awesome part about recording for students is that it really provides a link between that visual representation of the pattern and the abstract mathematics in the equation or in the table. And most students, honestly, are going to need that. Not all of your students, but to really going to support most. I know I benefit from seeing the equations, the tables, matching what I see in the visual. It helps solidify my thinking. The visual pattern superpowers that are used in math help students develop a deeper understanding of mathematical concepts, build foundational skills, their problem solving, their reasoning. It's really laying the groundwork for algebraic thinking. We recommend that educators use talk moves as a facilitation strategy for promoting classroom discussions. These talk moves prove to be a game changer in promoting student agency. And I know the poster that is on display there says math talk moves, but here's a secret that you probably know. They can be used in any part of the day, any subject. So revoicing. Oh, so you're saying that you knew 4 + 3 is 7 because you knew 3 + 3 is 6, and you added one more. And it could be the teacher's revoicing, it could be another student's revoicing. Repeating is hands down my favorite. So here's how we recommend teachers use repeating. Not in a punitive way, which I have used this in teaching in a punitive way, and now I regret it. Johnny, can you repeat what Sally just shared? Oh, you can't because you weren't listening. Come on, Johnny. That's not how we recommend using repeating. Repeating is an invitation. Oh my goodness. Who heard Sergio's explanation of that visual pattern? Who heard it and can repeat it? Because that is worth repeating. And if no one heard, and we only use repeating when we think it's like a great idea, we do want to hover because we think, well, maybe a couple kids heard, but not everybody heard. So let's hover here for a minute. So then you say, Sergio, that was so awesome. Can you repeat that again? And then I'm going to ask again, I'm going to invite who heard what Sergio said and would like to repeat it. So I tell you what, our kids, they want to, most of them want to be talking. So if we're setting them up for success, hey, all you have to do is listen to Sergio, and then you can volunteer to repeat what he says. Then after that child, whoever you called on, repeated what Sergio said, you always go back to Sergio. Sergio, is that what you said? And, how did that kid do? And again, it's in a positive way. And because sometimes kids don't repeat what the child said, and Sergio can say, no, actually, this is what I said. And then you can give that child a second chance. Oh, okay. Can you repeat it now? So we're just really teaching kids there is value in listening to each other and to considering what each other says and being able to repeat it, to think about it. I honestly believe, and I bet you do too, students can learn probably more from each other than they can just from me, the teacher, because there's so many of them. So let's empower them with that technique. I love reasoning. That's the next talk move, and that's math routines are all about reasoning. Do you agree with? Do you disagree with? Why? How did you see it? Why did you see it that way? Can you explain that? Adding on is a favorite too. Who heard what Christine said and can add on to it? I'm always surprised, even down in kindergarten, that students have something to say about what Christine just said. It's amazing, but I've got to remember to ask the question. Who heard what Joe said and would like to add on to that thinking? And of course, wait time, something all of us need to work on, me included, and our favorite turn and talk. To summarize, remember that math routines are structured, repeatable activities in mathematics classrooms that provide a framework for engaging students in thinking, reasoning, and communication. They offer a predictable structure that supports both teachers and students, promoting deeper mathematical understanding and student agency, things we want from our mathematicians. They're honestly our favorite part of math class. We hear that from educators and students. Our hope is that you found this Math Routines Math Workshop useful in supporting you as you guide your mathematicians through math routines. We find math routines to be not only fun, as we've mentioned several times, and engaging, but extremely helpful in providing opportunities for our students to make sense of math concepts and develop deeper mathematical understanding. Again, laying that foundational groundwork for algebraic thinking. We have more information on our website that you see on the screen, themathworkshop.net, about these various math routines that you see on the screen and others that we didn't have time to touch on during this math workshop. So feel free to go to our website, locate the resources page, which is there's a snapshot on the screen of a smaller part of the resources page, and you'll find more information under math routines. There's more videos, there's examples. So thank you for joining us, and we hope you have a terrific school year. Thank you, if no one's told you today, thank you for what you're doing for our students. It makes a difference. Welcome back. Hopefully you enjoyed that and maybe learned some new things if you haven't been facilitating those math routines. Right. Let's continue on and wrap up. You also received these 3 math games to use with your students. So even an odd products game, addition and multiplication equations game, and the array game version too. So have fun with those. We recommend that you first introduce how to play the games, whole group with your students, modeling how to play and explaining the procedures and the rules, and then partnering students up, giving them the opportunities to play, and then coming back together and sharing what did you learn, what are some questions you're having, and then putting the games in a math center so that students can play regularly. You also receive geometry word wall cards, so print those, cut them out, and put them somewhere where you can reference them easily and they're in the line of sight of your students to support their thinking. So we're so excited to share that we have a part 2 of this series in supporting educators with 3rd grade math. It's called Keeping It Going in 3rd Grade Math Workshop, because we didn't get to everything in 3rd grade math during these 2 hours. We did not get to understanding the structure of rectangular arrays and of area. We touched on that some, but there's more to touch on. And we didn't get to describing and analyzing 2-dimensional shapes. We also didn't get to share about the math routines of tell me all you can, same and different, and counting around the room. And Mr. Fletcher did mention that one, counting around the room, how powerful that can be for students in supporting their fractional understanding. So we hope you'll sign up for part 2 of this series. Additionally, here are some other great workshops that we have, amazing math routines, procedural fluency and conceptual understanding, rich task investigations, fractions and decimals boot camp, math strategies versus algorithms, and small groups, math centers, and games. And we're always open to creating more, and we're always brainstorming new workshops to create. So if you have ideas, feel free to reach out to us and let us know. And thank you. Thank you for all you do. Lastly, we want to invite you to visit our website where we've included many free resources for you to assist you in teaching your third graders. Feel free to go over to our YouTube channel where we have a lot of videos for you. Some are on our website as well. And just know that we offer in-person and virtual coaching and math workshops for educators. So please know that we're a resource for you. And we just hope that you have a fantastic school year, whatever your situation is, wherever you are. And we hope you enjoy learning alongside your young mathematicians. So thank you for your time. And we hope our paths cross again.